Welcome to the MS-SQL Tips webcast, High Availability for SQL in VMware Without Raw Device Mapping, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS-SQL Tips and today's webcast host. Joining me today is Tony Tamarchio. Tony is the Director of Field Engineering for SIOS Technology, and today he will show us how to cluster SQL Server virtual machines. If you have questions during the webcast, please use the question area in your presentation controls to submit the question. We will try to answer as many questions as possible during today's webcast. If you have any technical issues with the sound or screen quality during the webcast, please use the questionnaire to let us know. If you're not already a member of the MS-SQL Tips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's webcast. So at this time, I'm going to turn things over to Tony, and he can get started.
Great, thanks Greg, and hello everyone. So my name is Tony Tamarchio with the Field Engineering team here at SIOS. And in today's webcast, we're going to be talking about methods to deploy highly available SQL Server instances, or failover cluster instances as they're known, in VMware environments without the shared disk requirement using raw device mapping. So for those of you who aren't familiar with raw device mapping, don't worry, we'll talk about how SQL is typically clustered in VMware environments. We'll talk about options you have to avoid the complexity and limitations that it imposes here. So I'm going to be using some terms here. We'll talk about Sandless clustering. A more technically accurate term here would be a shared nothing cluster configuration where you don't have a shared disk. And this type of solution works not only for SQL Server, but really for any clusterable service or application. So SQL Server is, probably the number one, type of application that I talk to customers about protecting. But if you have a highly available file server or some other critical application that you need to make highly available in your VMware environment, this will work for any application that you might want to throw into a cluster. But we're going to be focusing, of course, here on SQL Server and a way that you can deploy this in VMware without losing a lot of the hypervisor level functionality that you depend upon in your VMware deployments here. So let's move ahead. But before I get into some of the content, I just want to do a quick poll here. So I want to figure out how folks out there are providing high availability for SQL Server in their VMware environments today, if at all. So Greg, if you could pull up the poll. So here, if you could answer, how are you providing HA, or high availability, for SQL Server in your VMware environment today? So are you using always-on availability groups? Have you deployed a shared storage cluster using raw device mapping? Are you just using VMware HA? Are you running without HA? Or are you using some other technique here?
All right, we'll give it like another 10 seconds to get the rest of the votes in, and I'll show the results.
Okay, sounds great.
All right, that's a good majority of the people voted, so I'm going to close that, and I'll share the results.
Okay. All right, so we've got a little bit of everything out there. So we've got 39% of folks are using always-on availability groups. Okay, so we'll talk about how this type of a solution differs from always-on availability groups. If that's working for you, great. If you're looking for a higher level of protection and maybe a lower administrative overhead, we'll talk about ways you can do that. We do have a number of folks who, 33% of folks are doing a shared storage cluster using raw device mapping. So for those of you out there who are doing this, you're probably aware of some of the limitations. Could be a pain point that you're looking to get away from. We'll talk about how you can address that. We've got 34% of folks using VMware HA, which is the hypervisor level high availability, basically protecting you against host failures, and then other folks are doing other, and 18% are have no HA. Okay, good to know. Great, thanks very much, Greg. Okay, so let's jump into the content. I've got a handful of slides. We're going to talk about the typical way of clustering, how you've got different options to do this. We're going to be talking about a product that SIOS has called DataKeeper Cluster Edition. And then towards the end, I'm going to switch gears, and I'm going to give you a live demonstration. So show you how you can configure a cluster without raw device mapping, without shared disk, and still achieve full high availability for SQL Server. So for the third of you on the line out there that have set up a cluster using raw device mapping, this is essentially what you have. This is a typical cluster diagram where you've got a couple of servers. Again, this is how it's done with physical servers, with virtual servers, really in any environment. So you have 2 or more nodes, and they're connected to some type of shared storage. Now, in a VMware environment, the way that you generally are going to connect VMs to the shared storage beneath it is using raw device mapping. What raw device mapping does, if you're not familiar, it allows a virtual machine to directly access and use the shared storage device, the stand behind your VMware configuration. And failover clustering requires that because it needs to manipulate SCSI reservations so that the active cluster node can touch the shared disk, and you don't get the wrong server touching your data at the wrong time, which could have impact and potentially corrupt your data. So it's important that the right node, the active node in the cluster, is the only one touching the storage at any given time. So now when you configure raw device mapping, the issue with that is there are a number of limitations that you run into. Now these can vary slightly based on the version of VMware that you're running, but commonly you'll lose features like vMotion, consolidated backups, snapshots, and things like that. And those are key features that VMware provides, and you don't want to lose those just to achieve high availability for SQL Server. So what we're going to talk about moving forward is a way that you can really have best of both worlds. You can still have SQL high availability, but you don't have to lose any of the VMware level features here. Now another limitation to a traditional shared disk configuration is, both nodes are dealing with a single copy of your data. So technically the shared disk in that type of a configuration is a potential single point of failure. Sure, SANs have redundant disks and controllers and things like that, but you'd be surprised how often I'm talking to folks and they'll describe a situation where the SAN went down, or they had a SAN level outage and it took out an entire cluster. So the whole idea behind a cluster and high availability in general is to eliminate as many potential single points of failure as possible. That's why you've got redundant servers, you've got redundant storage, you want redundant network, all of that, so that there is no single point of failure. So where SIOS comes into play is we enable you to deploy what we call a Sandless cluster, or a shared nothing cluster. And this greatly simplifies your deployments here, because now what you can do is you can take those 2 virtual machines, but you no longer need to configure an RDM. You can simply give each virtual machine their own VMDK files. And because they're just VMs with VMDK files, you still can leverage all of the VMware features that they provide. You can vMotion your virtual machines from host to host. You can back them up properly. You can take snapshots and all of that. When you're doing a configuration like this, you just do want to be mindful that you don't want both virtual machines to be on the same physical host, because then if the physical host dies, it can take out your entire cluster. Now, so generally you'll want to set up things like anti-affinity rules so that the virtual machines are always running on different physical hosts. But in this situation here, you've got your 2 virtual machines. Now you certainly could have more than 2 if you want a bigger cluster. And SIOS has a product called DataKeeper Cluster Edition. And what it does is it replicates the data between your SQL servers in real time. So think of this like a software RAID 1 mirror going across the network. It's disk-level replication, and again, because it's disk-level replication, not only does this work for SQL Server, but this will allow you to replicate and protect and make highly available any other service or application that you're interested in protecting as well. So DataKeeper performs the replication at the block level. So DataKeeper has a filter driver that sits underneath the file system, and as data is written to the primary system, it replicates it block for block over to 1 or more target systems here. So this can be done synchronously or asynchronously, which is nice because now this gives you a solution to replicate your data, whether it's all in one data center with a high-speed, low-latency local area network connection, or this also could be used in multi-site configurations. Perhaps you want to do a Geo cluster now, and you want to have one virtual machine in San Francisco and another virtual machine in New York. So a multi-site cluster is really the best of both worlds. It gives you both HA and DR essentially in a single configuration. So you've got your configuration, you've got 2 or more virtual machines, there's no shared disk, your VMs simply have VMDK files attached. You just want to make sure that the drive letters and sizes match between the 2 VMs, but other than that, that's really the only requirement here. So data is being replicated from the source to the target, and just like you would expect with any SQL cluster, if the active node dies, failover takes place, and SQL Server is brought online on another node in the cluster. Well, when that happens, it talks to DataKeeper or DataKeeper Cluster Edition under the covers, and it tells the direction of replication to switch. So this is nice because when failover happens, the underlying replication engine is automatically reconfigured. You don't need to manually worry about, oh, where's SQL running and is the replication going and is it going in the right direction. That all just happens automatically here. So, and just to clarify another point here, so this is still just a typical Windows and SQL cluster. So you enable Windows Server failover clustering feature within the operating system as you always would, and you would install a clustered instance of SQL into that Windows cluster. DataKeeper is simply a replication software that you install on top of the cluster nodes to basically eliminate the shared disk requirement from that traditional Windows and SQL cluster here. So it's not a new failover technology. It's you can reuse the skills that you already have with Windows and with SQL clustering, and now we're really just abstracting the storage and making independent replicated disks look and feel and act like it was shared between the different nodes. So, if you already have an existing cluster, that's fine. You might want to keep what you have in place, and maybe you want to have some added protection. So maybe you want to add a third node at a different data center. That could be your data center. That could be up in the cloud. And you could certainly keep the existing shared disk cluster with RDM. For the third of you that have that configuration today, maybe you want to add another node. This is a great way to expand upon an existing cluster and add remote failover or DR to a different data center, or this even could be a virtual machine up in the cloud somewhere. So again, as long as the drive letters and sizes match, you can kind of mix and match the systems involved here. So that's one way. If you had an existing cluster, you want to add some additional protection. The other thing you could do is you could get rid of that shared disk completely and use DataKeeper to replicate to both systems. So DataKeeper supports multi-target replication. So for example, node 1 on the left, it can replicate to node 2, which in this example would be at the same data center, and then it could replicate to node 3, which would be at a different data center or even up in the cloud. And you can have different replication modes between different targets. So for example, between node 1 and 2, you could configure synchronous replication, and between nodes 1 and 3, you could have asynchronous replication. So when you select your mode of replication, that's really, it's a business decision, and it's the classic trade-off of performance versus potential data loss. With synchronous replication, there is 100% data protection. There's 0 data loss. Each write that comes down is a double commit. So when that data is written to disk, you know that it has safely been written to both source and target sides of the mirror. But the round-trip latency in your network will have somewhat of an impact on your write performance. I've got some performance slides here we'll talk about a little bit later. So it can slow down your writes a little bit, but you will have 0 data loss. So maximum protection. Synchronous replication is always preferred if your network allows for it. Nobody wants to lose data. Now, if you do asynchronous, you still have real-time continuous data protection, but in the event of a hard failure, there could be some slight data loss, some data that was in the queue that had been written to the source but hadn't quite made it over to the target. you're generally talking handfuls of blocks, not minutes or hours or days here. So you still have crash consistent data. There just could be slightly behind. So you can make that decision as you deploy a solution like this, based on your recovery time and your recovery point objectives and your network characteristics, which mode makes the most sense for your business. But DataKeeper supports both synchronous and asynchronous. So the number one question that I get asked in meetings and on these types of webinars is, well, okay, so SQL Server, starting with 2012, has a feature called always-on availability groups, and that allows you to deploy a similar architecture. You can have SQL servers, there's no shared disk requirement, so that is a quote-unquote Sandless or a shared nothing high availability architecture. But there are a lot of differences, and there are some limitations that you should be aware of. So the first one, really comes down to cost. If you do decide to leverage always-on availability groups, that is a feature that is provided with Enterprise Edition. So if you're using Standard Edition of SQL today, you're looking to minimize costs, maybe you're on Enterprise today just for the HA features, but you want to reduce your costs without sacrificing high availability, you want to do this with Standard Edition. Microsoft allows you to form a 2-node failover cluster instance using Standard Edition. Now, if you go to 3 or more nodes in the same cluster, well then, you would have to go back to Enterprise Edition. But if you just want high availability in a 2-node configuration, you can do that with SQL Server Standard Edition. So that's one difference. And in this chart here, always-on availability groups is the column here on the left. An always-on failover cluster, or an FCI, a failover cluster instance, that's your typical shared disk, traditional SQL cluster, as most people would know it. And then on the right, really this is, again, it's the best of both worlds. It's a full failover cluster instance with SQL, but it's using DataKeeper as the disk underlying disk replication technology. So you kind of get you get both full HA, but you also get the the elimination of the shared disk requirement here. So those are the 3 columns you see here up on the screen. Also, in SQL 2012 and SQL 2014, always-on availability groups, it's not compatible with distributed transactions. So if you rely on MSDTC, if your application uses distributed transactions, that's not, availability groups aren't going to work for you. So it will work with a failover cluster instance of SQL Server. And of course, it will also still work with DataKeeper. The fact that DataKeeper is replicating disk and that there's no shared storage between the cluster nodes, that's completely transparent to SQL Server. That's completely transparent to the applications that are connecting into the database. We're just basically keeping the disks synchronized between your systems, and we're making the cluster think that there's shared storage when there really isn't. So to get back to the slide here, also the third line, availability groups does have upper limits on the number of databases per availability group and the number of availability groups per SQL instance. You don't have those limitations with a failover cluster instance of SQL Server. You're just limited by whatever SQL Server itself limits you to. Also, availability groups is only going to replicate the user databases. So your system databases like master, MSDB, your SQL logons, your SQL agent jobs. Availability groups isn't going to replicate and protect and fail those over. You're essentially dealing with 2 standalone SQL servers with glorified database mirroring here. So if you want full instance level protection, you're managing 1 instance of SQL Server as opposed to 2 instances with database replication, a failover cluster instance is going to work better for you here. That leads to the next point, which is easing database administration. Again, with a failover cluster instance with DataKeeper, you have 1 highly available instance of SQL Server as opposed to 2 standalone instances that are doing database level replication here. So there are half the number of SQL instances running and that you need to manage out there. Also, DataKeeper, because it is a disk level replication technology, it can replicate any type of data, not just your SQL databases. So this is great if you have an application that sits on top of SQL Server and perhaps some data lives outside the SQL database. on the file system. And maybe it's PDF files or text files or some other type of data that's not in the database. With DataKeeper and a Sandless cluster here, you essentially are telling DataKeeper which drive letters you wish to replicate. Whatever data happens to live in those drive letters is going to be replicated and protected in real time. So again, it could be SQL, databases or logs. It could be PDF files. It really could be anything. So you can fail over more than just your SQL databases and make, the entire stack highly available here and protected. I do have a slide, the next slide here, that talks about replication performance and efficiency, but you're going to see better replication, you're going to see better performance with a Sandless cluster like this. Availability groups is generally going to impose more overhead when you're dealing with synchronous replication and slow down your database more than a DataKeeper-powered Sandless cluster here. Okay, so those are some of the primary differences. If you're familiar with availability groups, those you're probably aware of some of those limitations here. But wanted to call that out. And with a failover cluster instance, again with DataKeeper, it's really the best of both worlds. You have the shared nothing aspect of availability groups, but you have full instance level HA and failover that you would with a traditional failover cluster instance. But again, without the shared disk, meaning in VMware you don't need to configure raw device mapping and lose a lot of VMware features here. So, performance is also a pretty big differentiator here, and I've run a number of tests in our labs, and we've seen this at customer sites, where, here's one example where we took a standalone SQL server, and in this particular example, we ran a workload just to simply insert rows into the database as fast as possible. Now, these were pretty, high-end systems. The VMs had, and the hosts had, high-end SSD storage in it. So in the standalone SQL Server configuration, we were seeing over 1 million rows per second being inserted into this database. Now we took, 2 identical VMs, formed a Windows cluster, installed SQL, installed SQL in the second node the same way, configured availability groups, and with synchronous availability groups, it dropped the performance down to around 250,000 rows per second. So it was, pretty significant level of overhead. So we've got these high-powered systems with fast storage, and then, you've got your replication technology that's really, negating most of the performance benefit that you've got here from this fast storage. So it really dragged things down. And in this particular example, we've got 10 gigabit connectivity between systems. We've got a very fast network, very high speed, very low latency, so that we can get data from point A to point B as fast as possible. But with availability groups, it was slowing things down pretty significantly here. So now we turned off availability groups, and we did the same replication, same workload, but this time with SIOS's DataKeeper Cluster Edition product doing the real-time block-level disk replication. And here we were only seeing, around 15% or so overhead. So a lot less overhead. You don't want your HA solution. You don't want to lose performance just to get HA. So now again, it's kind of another best of both worlds. You can maintain a fully highly available SQL server and not drag down performance while doing so. So minimal impact on that. Now, I often get questions a lot about, does this impact, reads too, and the answer is no. DataKeeper only gets involved when data is written to the disk. We only then send a copy of the block over to the other side. When reads are happening, DataKeeper doesn't get involved at all. There's no impact on your reads. DataKeeper only gets involved when writes are being made to the disk. Okay. So with that, let me switch gears, and I'm going to bring up a live demonstration and show you how to configure a cluster, or basically how to set up a DataKeeper mirror which registers a cluster disk with failover clustering, and then we'll open it up for Q&A. So I'm connected into a cluster that I have set up, and my cluster is called SIOS WSFC, or Windows Server Failover Cluster, .demo.local, and it's a simple 2-node cluster. My nodes are called SIOS 1 and SIOS 2. Now, for those of you who have an existing cluster in your environment today, you're doing raw device mapping and all that, most of this is going to be familiar, but there are couple of key differences. One, first of all, in my configuration here, there is no shared disk. So these are two VMs. They each have the same number and same size VMDK files attached. That's one. So there's no shared storage. And DataKeeper is going to be providing a replicated disk resource to the cluster, and I'll show you how we set that up here shortly. One other difference that you'll notice is with the witness or the quorum model that's configured here. So in a shared disk cluster, you would typically have a disk witness or a quorum disk, as it's also sometimes called, where you carve out a small line on the SAN, and that would be the quorum disk or the disk witness. When you have a shared nothing or a SANless configuration like this, you don't have shared storage between the systems, so you would configure a file share witness instead. That's just it can reside on really any Windows system out there. It's just a folder that you create and you share it out on the network so that the cluster can access it. So it uses that instead of a disk witness. So those are the two kind of architectural differences here, pretty minor. So if I take a look at my cluster, I've got a couple different cluster roles. You can have multi-instance SQL clusters. You can have multiple applications. Again, this works for SQL Server and really any other application or database out there. So here with my clustered instance of SQL Server, right now it's running on node 1, and this all should look very familiar. I've got my virtual name, my virtual IP. None of that changes. I've got the SQL Server resource. I've got the SQL Server agent resource. But then up here at the top, I've got this DataKeeper Volume S resource. So this is different from what you might be used to. This is what DataKeeper provides. So what DataKeeper has provided is what's called a third-party, what Microsoft would call a third-party storage class resource. So we have a replicated volume resource. It looks and it feels and it acts like a shared disk. But here, in this case, I've got this DataKeeper Volume S. It's not actually a shared drive. I have an equally sized S volume on SIOS 1 and SIOS 2. DataKeeper is synchronizing the data in real time continuously at the block level. Again, think software RAID 1 mirror, but going across the network. And then we present that pair of mirrored volumes to the cluster as if it were a piece of shared storage. And I'll do a failover in just a moment. We'll show you that it brings it online and it switches the direction of replication automatically. So here I've got my clustered instance of SQL Server. If I look at the cluster disks here, I've got a couple of these already in the cluster, and they're already assigned to the two cluster roles that I've configured. We're going to create another DataKeeper mirror and cluster disk resource here in just a moment. Now the way that you do that is via the DataKeeper UI. So I'm pulling that up right now. It's a simple MMC snap-in, very easy to use. I'm looking at an overview screen right now where I can see the servers involved. So I've got this sios1.demo.local and sios2.demo.local. And you can see here up at the top that I already have my K volume and my S volume already mirrored. I can see the roles here. So SIOS1 is the source for both of them. So data right now for these two drive letters is replicating from SIOS1 over to SIOS2. I've got a couple of other drive letters here. T is where I've put tempdb for my SQL instance, and notice there is no mirror there. That's on purpose because there's no need to replicate tempdb. It gets thrown away and recreated upon failover anyway. So you could replicate it, but you'd just be creating unnecessary replication traffic. So if you're on SQL 2012 or newer, best practice is to move tempdb to another volume, and you would not replicate that here. So I do have this R volume, and that's what I'm going to create a new mirror for right now in our session here. So I'm going to create a job. We'll call it R drive. Oops, a typo in there. And I'm going to click Create Job. Now this is a three-step wizard to create this new mirror. And the end result of this is going to be my data is going to be replicated from source to target, and it's going to register a new disk with the failover cluster that I could then use with an existing or a new instance of SQL Server. So first I'm going to select my source, then my target, and finally my mirror details. So my source will be SIOS1. Now if you have multiple network interfaces, maybe you've got multiple virtual NICs and virtual switches and things like that configured in the environment, you do have the ability to decide which network interface you use for replication specifically. If you only have one, that's okay too. But if you can separate that, that's always a good idea. So you have one NIC for your public traffic, if you will, for your client and application traffic, and then if you have a second NIC for replication traffic, then those two NICs aren't competing for bandwidth potentially. So I have this 10.10.10.1 network, and that's what I use for replication. I'm going to select the drive letter that I wish to replicate, in this case R, and I'm going to click Next. On step 2, I'm selecting my target, so there's actually nothing for me to change right here. It's automatically selected the other server, the appropriate network card on the same network, and the matching drive letter. And then finally, I have my mirror details, and this is where I can decide which mode of replication I want to use. I'm going to select synchronous because these two systems are in the same data center, so they're connected via high-speed, low-latency networks. So I've got 10 gigabit back-end networks here. And then I do have the ability to throttle the replication. Generally, you would only use that in a WAN type configuration if you don't want to have DataKeeper potentially use up all your bandwidth. But the whole point of replication like this is with real-time replication, you want to protect your data, and we want to replicate that data as quickly as it gets written so that you've got maximum data protection here. So generally, I don't recommend enabling the throttling unless you really need to. You also can enable compression if you want to reduce the amount of data going between source and target. Again, that's typically only done in WAN or Geo Cluster type configurations. So I'm going to go ahead and click Done, and we'll create this mirror. So it's going to create this brand new mirror for my R drive, which is going to take just a moment here. And once that's been completed, the initial sync will take place. So it'll copy all the data, replicate all the blocks from node 1 to node 2, from SIOS 1 to SIOS 2. And what you'll see on the screen right now is it's asking me a question, and it's asking me if I want to register this new DataKeeper mirror with the failover cluster as a cluster disk. So I'm going to go ahead and say yes. Now if I go back into the cluster, I can see here that I'm looking at the cluster disks once again, and I have this brand new DataKeeper volume R. It's sitting right there in the cluster's available storage pool, and at this point, this is just you're dealing with this is clustering 101. This just looks and it feels and it acts like shared storage. The way that you manage your clustered instance of SQL Server, the way that you install SQL into the cluster, and none of that changes. None of that changes. So what you're used to seeing today, it's all going to be preserved here. It's just we're really abstracting the storage behind the scenes. We're synchronizing the data. We're making independent replicated disks look like a piece of shared storage to the cluster. So let me show you failover. Again, failover works the same way as any cluster you've seen before. So right now my SQL Server is running on node 1. I'm going to go ahead and fail it over to node 2. Click OK here. And what it's doing, like it does with any other cluster, is it's offlining the resources on node 1, and it's going to online all the resources back on node 2. And as part of that, it's onlining the DataKeeper volume resource now on node 2, which is under the covers telling DataKeeper to switch the direction of that particular mirror. So it's going to flip-flop the source and target roles. Now my data is being replicated in the opposite direction from SIOS 2 back to SIOS 1. And I can show you in the DataKeeper UI that change has actually been made. So let's take a look. I'm going to switch back here. So a couple different ways we can look at this. I'm looking at the overview screen once again, and I can see here that the role for the S mirror has changed. SIOS 1 used to be the source for the S drive. Well, now it's the target. So in this situation, I actually have different drive letters replicating in different directions. So you could have one SQL instance on node A and a different SQL instance on node B, where they're both replicating their data in opposite directions to the other node, and essentially a failover for the other one. So you can do a kind of an active-active multi-instance configuration where the different instances are running on different nodes. Now, of course, with any SQL cluster, a given SQL instance is only running on one side of the cluster at any given time. So that's switched. Another way you can look at this is if you look at the job itself. Here I can see that my source and target roles have switched. So SIOS 2 is the source, SIOS 1 is the target, and I can see other pieces of information about this mirror. I can see who what the IP endpoints are, the mirroring state. I can see down below the type of mirror. So this is a synchronous mirror. The S drive is around 1 terabyte or so. So you can get a lot of great information about your mirror. If, for example, the mirror was interrupted and it might be in a paused state, or maybe it was temporarily interrupted and now it's resyncing again, it could be in a resyncing state. You can see how much data is outstanding between your source and target. So any event that takes place with your cluster or with the DataKeeper mirrors, all of that, of course, is logged to event viewer, so you can track and see what's going on at any given time here. So the nice thing about this is really once you configure the DataKeeper mirror through that 3-step wizard that I showed you, you generally don't have to go back into the DataKeeper UI. You kind of set it and forget it, if you will. And you live your life in Failover Cluster Manager like you always have, if you've been doing this with shared disks and raw device mapping in the past. So, you already know, anybody who's deployed a cluster before, you already know, 99% of how this all works. DataKeeper is really just eliminating the shared disk requirement from your cluster. So just to wrap things up here, just a little bit more information on SIOS. We've been around since 1999, so we've been protecting mission-critical applications and data for well over a decade. We've been focusing here on our Windows solution, DataKeeper. We also do have solutions for other operating systems as well. And again, you can protect any application, not just SQL Server. We're a global organization. SIOS is a Microsoft Gold partner, and DataKeeper is logo certified for Server 2008 R2 and everything newer. So as far as Microsoft is concerned, this is a fully supported cluster. You're not going to have any issues with support if you change to this type of a Sandless model here. So with that, I guess at this time, Greg, why don't we open things up for Q&A? I do want to thank everybody for their time and interest here today. And if there's any questions that we haven't addressed yet via the chat, would be happy to discuss those at this point.
Great, thanks, Tony. Yeah, actually, Dave has answered a lot of the questions. So Dave, I don't know if you want to jump in and go over some of these questions that you've already answered that may be useful to the rest of the audience.
Yeah, sure. There's a lot of common questions. Maybe I'll pick out some of the more common ones. So people are asking, can you use this on physical servers and Hyper-V and cloud? And yes, this works with all those platforms. So physical virtual cloud, Hyper-V, VMware, AWS, Azure, all those, everything supports, that works fine. There's a lot of questions about the consistency of the data upon failover. So there's synchronous mode, asynchronous mode. In either mode, it really works exactly the same as a shared storage failover cluster. If you were to pull the power cord on the active node of a failover cluster, the data is kind of in this flux state. Maybe some transactions were in flight, and the data is what's called crash consistent. And so the backup node would come online and look at the log files, look at the data files. Because they're at the same point in time, SQL will do a soft recovery. We'll be able to mount those databases and roll back those uncommitted transactions. Same exact thing happens with DataKeeper. Now, synchronous, all the writes are going to be there, so you're not going to lose any data, but there will be a soft recovery that occurs. Asynchronous, you might be a few writes behind, but still the write order integrity is maintained, so the data is crash consistent, so SQL will be able to bring those databases online. Just as if you walked up to a standalone instance, the SQL pulled the power cord, turned it back on, a soft recovery is going to occur. So that was a common question. Let me roll through some of these other ones. And maybe throw some at Tony here so you can have a crack at these. Let's go back to the beginning here. Performance, Tony. Can you talk about performance a little bit? People are asking, like, what determines whether you see, for synchronous replication, where you see 5%, 10%, 30% overhead. I answered that, online here, but maybe you could add some flavor to that.
Yeah, certainly. So, the biggest factor in synchronous replication performance, is going to be the latency in the network. So, think about it this way: with each write that comes down, it's double commit. So it's written to both servers, and it's sent to the standby node. We wait for the acknowledgement and all of that. So round trip latency is going to be a factor. So if you have 5 milliseconds of latency, think every write that comes down is basically you're going to add 5 milliseconds to it. So that's why you want to have a very high-speed, low-latency network. In most cases, let's assume you've got a very high-speed, low-latency connection like sub-millisecond latencies and things like that. In most cases, we're seeing somewhere around 15 to 20% overhead that's imposed by synchronous replication. That will vary based on the size of the writes and the number of threads that are writing to the disk at the same time and things like that. So unfortunately, there's no fixed. I can't say, well, it's always X percent. It will vary. But what you can do to maximize that is have the the fastest kind of lowest latency network connection you can between the systems here. Make sure that also your disks are, of course they need to be sized accordingly, but make sure that they're the same speed. If you have a standby node that's connected to its VMDK files on a slower data store and your active node's on a faster data store, well, that slower data store is going to slow everything down because you can only write as fast as you can write it to both sides. So make sure that the performance characteristics of the storage attached to these systems is also equivalent here.
Great. So a lot more questions are coming in, so we would answer some of these I haven't gotten to yet. Question is there a max link latency for long-distance asynchronous replication?
No, there's no maximum latency. I'll also get a kind of a spin-off question. Well, what's the maximum amount of latency you can use for synchronous? And the answer is, well, you saw in the demo, it's a radio button, and you can select whichever radio button you decide. So, if you had 50 milliseconds of latency, you could do a synchronous mirror if you wanted, but you just have to be okay with 50 milliseconds added to each write. But perhaps in your particular business, it's way more critical that you don't lose a single block of data. Maybe it's financial transactions or things like that, and you're okay with the slowdown there. So we don't have, DataKeeper doesn't have any bandwidth requirements or latency requirements per se. With the bandwidth, you just need to make sure that you've got sufficient bandwidth so that your rate of change fits within the bandwidth. And then you want to have as low latency network as possible, especially with synchronous. But DataKeeper doesn't, it's not going to break or bomb out on you or not let you create a mirror in a particular mode because it detects a certain amount of latency. You can select whichever mode is most appropriate for your business requirements.
Yeah, just to add to that, I think the question was about async, and to reiterate, there's really for WAN replication, the main concern is the speed of the connection, that you make sure that you have adequate bandwidth compared to your rate of change. But latency is really overcome because we have a lot of WAN acceleration already built into the product, so we don't see high latency causing an issue with long-distance replication. Here's a good question. If there's a network breakdown between the two data centers, does Splitframe become a problem?
Okay, great question. So a lot of the Splitframe protection is built actually into failover clustering. So that's why you have, for example, the file share witness. So let's say you were doing a 2-node Geo cluster, one node in San Francisco, one node in New York. Well, generally what you would want to do is you would want to have a file share witness, and that preferably would be at a third site, so say Chicago. And the cluster protects you against Splitframe because if the two sites lose connectivity to each other, but they can still see the file share witness, well, what's going to happen is you're not going to have any false positive failovers. If the node at the DR site loses network connectivity and it can't see the file share witness, the cluster service on that node is going to go offline. It's not going to come online if it doesn't have majority. So failover clustering itself protects you from getting into that Splitframe situation. If a node loses quorum, the cluster service will go offline. Now, DataKeeper also has some protection mechanisms there. If the mirror does get interrupted, let's say the WAN link goes down between San Francisco and New York, well, each DataKeeper mirror has a bitmap file, and this is where we track which blocks on disk are in sync versus out of sync. So when the network does come back up, we know what that delta is, and DataKeeper will automatically perform a partial resync. So it protects you from having to do a full resync of your entire data set, which could take quite some time. time depending on the size of that data set.
Great. Question is, what about the SQL cluster name connectivity for applications since instance name is changing?
So the instance name isn't, with a failover cluster instance, you have one clustered instance of SQL Server. So when you install the clustered instance of SQL into the cluster, you specify a network name and an IP, and it actually creates a virtual computer object in Active Directory for the clustered instance of SQL Server. So when you fail over, the name of the SQL instance does not change. So that doesn't impact your applications. They're still connecting in the same name, and they're just being redirected to the currently active node in the cluster.
Mm-hmm. It's a question about alerts. How do you set up alerts for off hours?
Okay, so DataKeeper, any event that takes place, whether it's a mirror state change or a mirror role change, all of that gets logged to Event Viewer. DataKeeper doesn't send out any email alerts or things like that itself, but if you have tools that scrape Event Viewer like SCOM or other monitoring tools, it can look for those cluster events or DataKeeper events and notify you via its mechanisms here. But DataKeeper itself doesn't do any type of alerting. It just logs everything to Event Viewer.
Great. Question is the replication set up on the guest level and not the host level?
Yeah, that's correct. In a VMware environment like this, you're installing DataKeeper inside the Windows virtual machines. So it's going from guest to guest. You're not installing anything at the the ESX level here. Now for Hyper-V, you have an additional option because Hyper-V, if you're using Hyper-V instead of VMware, Hyper-V is simply a feature on top of Windows Server, so you can actually do replication at the host level in Hyper-V environments, and for example, replicate entire VHD files from one Hyper-V host to another Hyper-V host. So you've got that extra option in a Hyper-V environment.
Great. Question, what about a 4-node Geo cluster with 2 in New York and 2 in Oregon? Can you set up intelligence for local synchronous and then async for the long distance replication?
Oh, most definitely. Good question. Yes, you can. So you can configure the mode of replication on a per target basis. So yeah, you could have synchronous replication from node 1 to node 2, and then you could have asynchronous replication from 1 to 3 and asynchronous from 1 to 4. Now keep in mind, if you're doing a purely Sandless configuration with 4 nodes, you're going to have 3 copies of your data going across the network. You're going to have node 1 is going to replicate to node 2, and 1 to 3, and 1 to 4 all in parallel. So, just again, to Dave, your comment earlier, you want to be mindful of bandwidth and make sure you have enough bandwidth between sites to support your data's rate of change, and in this case, to support double your rate of change.
Right. 2 targets, double
Yep.
double the data being sent. Awesome.
Exactly. Yep.
In the same vein here, the question is, what's the overhead for async replication?
So the overhead for async, well, generally there's no noticeable impact for async replication because it's a single commit. The write comes down to the active node immediately, and then we queue up the writes to go across the network as fast as possible here. So typically there's no noticeable impact with asynchronous. And as far as system resources that are used, I mean the DataKeeper, the driver uses a few megs of RAM. You're not going to see noticeable CPU utilization unless you turn on compression, in which case CPU cycles will be used on each end to compress and decompress the data. So other than that, it should pretty much be unnoticeable in async configurations.
Yeah, and even the compression, you had 9 levels to choose from, and I found that even the first couple levels are going to give you a really good compression ratio with minimal CPU utilization. So
yeah, exactly.
Usually not an issue.
Yeah, exactly.
So back to that question where the network goes down. We talked about the network going down and then using the bitmap files to track. So what happens when the network comes back up? How does SIOS deal with that?
Okay, good question. So when the network goes down, what happens is the mirror automatically gets paused. And while the mirror is paused, we're using the bitmap file to track the changes that have been made to the source that haven't yet been replicated to the target. So this bitmap file is very small. Basically, there's 1 bit in the file for each block on the volume. So for example, if SQL writes to block 7 on the disk, then we dirty bit 7 in the file, and then we write to block 99 on disk, we flip on bit 99. Well, when the network comes back up, the mirror will resume, and DataKeeper goes into what we call a resync state. And in that state, what it does is it consults with that bitmap file to see, well, okay, block 7 is out of sync and block 99 is out of sync. So it consults the bitmap file to see which our quote-unquote dirty blocks are, the ones that haven't been made it across, and it just copies those ones over. So it protects, that bitmap file protects you from having to do a full resynchronization of your entire volume, after a mirror is interrupted here.
Great. Question is, can you provide documentation of installing DataKeeper and SQL configuration? I think that's pretty obvious. Absolutely, we can do that. There's contact information on that last slide here, and I'm sure we'll be following up with all the attendees, so we can certainly get you documentation and video demonstrations and eval software and all that good stuff. It'll work.
Perfect, perfect.
Great. So there's another question. Let me scroll up here, see there's some of the common questions here. What about updates to SQL Server?
Okay, great question. So the way you would update SQL Server is the same way you would update SQL in a traditional cluster. So generally that's done, you would do a rolling upgrade where, let's say you've got an active passive configuration. This applies to your SQL updates or even your Windows updates, even how you update DataKeeper itself. So typically what you will do is you'll apply your updates, your patches to the standby node. So let's say node 2, and reboot it. Once it comes back online, then you would fail the cluster over, bring node 2 online. Now node 1 is the passive node. You would apply your patches, your updates to that one, reboot if necessary, and then fail back. Or don't fail back, leave it on node 2. In a best practice configuration, both node 1 and node 2 are identical in every way, or they should be. And that means it really doesn't matter which of the 2 nodes you're running on. So that if you just leave it on node 2, that just saves you, one small downtime when you fail back.
Great.
So,
I'll take this next one. I think the question came in, says, what with lost data, are there points in time for recovery? So the replication is real time. So write comes on a source, it gets committed to the target, and the recovery by default is only the very last most current data. There's no points that you can rewind to per se. But we do have a feature called a target site snapshot. So you can, on the target system, periodically take a snapshot, and this is an application consistent snapshot, so it's integrated with volume snapshot service. And so you could do incremental snapshots, and then that snapshot you can do like a robocopy or something and copy that data off to some archive storage. So that gives you ability to recover should you have some kind of data corruption. Now the data corruption is going to be from the source. If the source, someone accidentally drops a whole table or a whole database or something along those lines, that's going to be replicated. So we're not going to protect you from those types of errors. You're going to have to go to your backup and to recover that. But you can leverage our target site snapshot to enhance your current backup strategy. So real-time replication is not a replacement for backups, so you want to just definitely continue your backups, and you can leverage our target site snapshot to enhance that as well.
excellent.
All right. So a lot of questions about the physical servers and virtual and cloud. Just to reiterate, it really doesn't matter. You can replicate from physical to virtual to cloud. We're seeing a lot of people leveraging the cloud as a DR site for their physical implementations and all that. And you can mix and match storage. Tony, you want to talk about the storage requirements?
Yeah, definitely. So basically, You just need to make sure that your drive letters and sizes match. Other than that, it could be one server could be a physical server with connected to a SAN, and the second server could be a VM with a VMDK file. Basically, it has to be block storage, so it has to show up under Windows Disk Management. You have to format it with NTFS and give it a drive letter. And then you want your drive letters and sizes to match between your source and target sides of the mirror. Technically, the target needs to be the same size or greater. It just can't be smaller, otherwise there wouldn't be enough blocks on disk to replicate all the data between them. So same size, matching letters and sizes.
All right. I've had a couple questions. People ask this question. Upon a planned switchover, either sync or well, typically I think this really applies to async.
Right.
On a planned switchover, is there any data loss?
No, there is not. In a planned switchover, as part of the switchover process for the asynchronous mirror, if there's any data in the asynchronous queue, that will be drained and it'll go across before it fails over. So you're not gonna lose data in a planned failover scenario, even with async.
Question is, so there's no integration with VMware. Is this just a volume partition replication? Again, this can use on physical servers. We answered that. You want to talk about, integration with VMware or lack of, and the features besides the replication?
Sure. So the asker of the question is correct. I mean, basically, DataKeeper is replicating Windows volumes. So we're not doing anything here that is VMware specific. So because of that, it works the same in physical, virtual, and cloud environments. You specify, as you saw in the demo today, which drive letter you want to replicate, and we protect the data between them. So this is a very powerful solution, especially in VMware environments, because if you wanted to do this, traditionally you would have to share a disk between the cluster nodes and use raw device mapping. This just gives you a lot more flexibility. But no, there's no special VMware requirements, and we're not doing anything special at the hypervisor level. We're just running as software inside the Windows guests, replicating the data from one Windows volume to another Windows volume on a different VM. So it's server and storage agnostic.
Great. Question is, can DataKeeper configuration or metrics be exposed to vCenter via a plugin or similar to manage view without leaving vCenter?
Okay, well, there's no plugins, or there's no DataKeeper plugin in the vCenter, so there's no tabs within the vCert client or anything like that. Again, there's the way that you would manage the cluster, that all is the same as the way you're doing it today, right? So you open up Failover Cluster Manager. So there's no direct VMware integrations to any of the components there, and it's just Windows software running inside the VM here. So as far as external tools, people might be using SCOM or things like that to monitor things or scrape Windows Event Viewer and things like that. But no direct integration with VMware components.
Yeah, DataKeeper also includes some perfmon counters.
Yeah.
So if there's tools that can can display perfmon counters, there's perfmon counters there as well. The question is, how would you go about updating the DataKeeper software? Is this the same method as with SQL updates?
Yeah, great question. Yeah, you would still do a rolling upgrade. DataKeeper is delivered as a setup.exe. It's very simple to both install it but also upgrade it. So you just run that setup.exe on the standby node. Click next, next, next a couple times, reboot it. Once it comes back online, then you would do a cluster failover, bring the newly patched system online, patch the original one, reboot it, and then you can decide if you fail back or not. But just a standard setup.exe and a rolling upgrade, so nothing special or different about that. You don't have to reconfigure or do anything like that. All of your mirrors and your settings are preserved during the upgrade process.
Great. Well, I think we got most of the questions. There's a few that we'll follow up with, but we're at the top of the hour, so I want to respect everyone's time. Tony, is there any last words you want to leave us with?
No, great. Just want to thank everybody for their time and interest here. Lots of great Q&A here at the end. Just to kind of recap in 30 seconds, if you're looking to deploy highly available SQL Server in VMware and you don't want to deal with the hassles or complexities of raw device mapping, this is a great solution. Again, Datakeeper provides real-time block-level volume replication that's cluster integrated and aware. And of course, this also works in other environments outside of VMware. Could be physical, could be any other hypervisor, or even could be cloud deployments. So, and it can protect not only SQL Server, but any other application you might want to make highly available as well. So lots of possibilities, lots of use cases for Datakeeper.
All right, great. Thanks, guys. So there are other questions, as Dave mentioned. What I'll do is I'll get those out to both Dave and Tony, and they can respond to each person as time permits. But at this time, I just want to thank Tony for presenting today, and I also want to thank SIOS for sponsoring today's event. For more information, visit the SIOS website or send an email using the links on the slide. The webcast was recorded, and you'll receive a follow-up email with links to view the archive and download the slides. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thanks for attending, and have a great day.
Great. Thank you.